Okay, so for number 1, when you're trying to write the equation in rectangular form, that's when we're going to have to use completing the square. Okay, and for this one, the first step is to multiply by r. So you can substitute x squared plus y squared in for r squared, and then r times the cosine of theta is going to be x. You want to move everything to one side, and then we're going to complete the square, which means we're going to do half of this b value squared to both sides. Okay, and then we're going to factor. 5 over 2 squared is 25 over 4, and then you can either leave this in decimal form or fraction form. All right, and then we are sketching your polar graphs. I'm going to show you some of my sketches. So for number 2, I just used some of the first points on my table, which you can get to in your graphing calculator. Do you guys need me to review with you how to get that table? Okay, so once you set up your table in your graphing calculator, remember, if you go by pi over 12, you're going to have a point for every single line. So that's exactly what I did here. And then I told you guys to label A, B, C, D, E. So these are my first 5 points, A, B, C, D, E, because what's happening is I'm going this way, and then I had some negative values. Whenever you have a negative value, you're going to go in the opposite direction. So it really is like a 180-degree reflection if it's negative, okay, from that line. So this is going to loop, loop, and there you go. Okay, now the second one, I noticed that here theta was in between 0 to 4 pi. So then I had to make sure that my points went up to 4 pi. So this was my table. Okay, so I use 0 pi, 2 pi, 3 pi, 4 pi. And this is going to be a spiral. I was doing so good, and then I got here, and then I was like, oh, I can just wing this around, and then it didn't turn out so good.
If it's a spiral, how many loops do you want us to make?
What's that?
If it's a spiral, how many loops do you want us to make? Because I just know that once.
Well, no, it's going to depend on your scale. So, see how it says theta is between 0 and 4 pi? So let's actually do this one. So if you do pi plus theta over 4, sorry, pi plus, and then in parentheses theta divided by 4. Let's make sure I am in polar, radian. Okay, so now I'm going to go to my window. So it says theta min, theta max. So this says my theta has to be between 0 and 4 pi. So I'm going to do 0 and 4 pi. Your stop's not going to matter. You can keep it as it is, or you can change it to pi over 12. Any of those are fine. And then we can go to our graph. Okay, so this is the number of spirals that you have to have for that because it's from 0 to 4 pi. If I change mine, so this is from 0 to 4 pi, so notice that I'm going to go around full once and then twice. If I change my window to 2 pi, see how I only have part of the spiral? Okay, what would happen if I changed it to 10 pi? I'd have more, right? I'd have more of the spiral. It would have more rotations.
Go to like 25.
Yeah. I think that one's pretty good.
Whoa,
Yeah. Okay. Alright, and then I scaled mine by 2s. So I saw some of you guys probably just started and then you didn't want to start all over. And you went off the graph. That's okay. That's okay for that. Okay, on your test, obviously, if you need to scale by 2, so it's all on your graph. Alright, and then the next one was also a spiral, number 4. for this one, it is 0 to 2 pi, so you are gonna stop here. And from what I saw from your graphs, most of your graphs look pretty decent. And then let's look at number 5, if that's okay. Okay, so for number 5, I'm gonna show you a specific point that I made that was B, and why I did this. So, when I made my graph, I noticed on my table that my back-to-back points were 2.6. But they are not gonna connect in a flat way. Now, did some of you have, on your calculator that it looked like it was flat? Well, I know some of you did, cause you told me, right? Okay, so if you are one of those people, all you have to do is reset your calculator and it should take care of that problem. Sometimes they do have the sharp edges to it. Okay, so I'm gonna graph. Okay, good. So, and sometimes when this is too small here, you can just go to zoom and zoom in. Okay, and then that'll give you a better picture of what's happening. So this is a rose curve with how many petals?
1, 2, 3, 4,
8, right? Okay. Now, when you go to your table, which I'm gonna set at 0 and go to pi over 12. You see how you get these two that are right next to each other? So, what you want to know is what happens in between these two. If you want to know what happens in between these, how could you find that point?
add them and then divide by 2.
Yes, okay, so halfway in between is gonna be pi over 6 plus pi over 12 divided by 2, but that point's not in my table. How do I find that?
Look at your calculator. Plug it in.
Yeah, plug it in where? For what?
Oh, into the equation.
For what?
Your theta.
For theta, right? So you could do 3 sine of 4 times this quantity, pi over 6 plus pi over 12 divided by 2. Okay, and that would give you that value that's right in between there, and guess what it's gonna be? Wow.
2.
3.
3.
3, right? Okay, so these should be, all the petals should have a curve there. Yeah,
I'm
that's
pretty
okay.
Pretty sure I had 0
These
for all of
graphs,
them.
will the lines be
Didn't
like
graph
standard?
anything, so.
What do you mean?
Like, if you just have a regular graph, if you get towards the center, they get all jumbled up and it's kinda hard to tell which one connects to which. So we'll have to see it randomized.
I mean, not necessarily. So you'll have to follow the points on there to make sure they're on the right line.
Yeah, so will they, on the test, will we see like straighter ones?
Oh, I see what you're talking about, like the actual
Like, yeah,
these,
not
yeah.
the graph
Right.
that you wrote, but the actual one.
I see what, no, they'll be the exact same. These will be the exact same coordinates. So if you do have trouble, you always know that whatever's 180 degrees from it is gonna have the same denominator. So if I'm trying to go negative and it's pi over 6,
Okay.
that'll be pi over 6. Does that make sense? Alright, and then for 6, we're gonna write a polar equation for a 4-leaved rose with leaves of length 3.5 that has a line of symmetry of theta equals pi over 2. So first of all, theta equals pi over 2. Think about where pi over 2 is on your unit circle, okay? It is gonna be right here. So this is that line of theta equals pi over 2. So basically, it's gonna be symmetric about, what else could we call this line? Yeah, the y-axis, right? It's gonna be symmetric about the y-axis. Now, how could I come up with this equation? What would I have to use? Or what would be a good thing I could use? Well, how did you guys find the equation? Did you just guess and check, or did you use something that I gave you, or something from the book?
I looked in the notes.
Okay, and then was there something specific in the notes that you noticed?
Yeah, on the second page of, not the second page, but
Okay, so that chart on page 2 of the common polar curves. Okay, so if we use that chart, that's going to help us. So first it said a 4-leaved rose. So if I look at my roses here, bless you, 4-leaved rose is going to have this form here. Okay, so then I can just use the same thing. Now for A, you could play around and you could see, okay, what is the A value going to be? You could also look at your examples. Let's look at actually number 5. What is my A value for number 5?
About
3. Okay, would you guys agree that 3 is my A value?
yeah,
How did that relate to this graph?
the length of petals.
It's the length of the petals, right? So even if you weren't sure what it is, look, now we have a way that we can do that just by looking at the equation. So you know it's just going to be 3. So for this, if you have 3.5, that's going to be your A value. The rest you're going to follow from the pattern, and then of course you can graph that and check that out. And I said, you guys had that hint. If you're having trouble, plug in values and see what they do to the graph, or you can use this chart. For part A, it says if n is a positive integer, how many petals does the curve have? Okay, so if n is a positive integer. So for this, like I said, I would use the chart. And it's 2n leaved if n is even. You also have that on your chart, 2 times n. So whatever your n value is going to tell you how many leaves that you have. Again, let's look at this one. So my n value for this is 4. So if it's 2n, 2 times 4 is what? 8. How many leaves do we have? 8. Okay, so you can figure that out just based on the pattern. If n is a positive odd integer, how many petals does the curve have? And that would be n leaved. And then what is the length of each petal? The length is going to be A, which we just talked about. Alright, and then for 8, determine the rectangular coordinate x and y for the given polar coordinates. So if you're going to change to rectangular from polar, the 2 equations that you want to use, I have written right here. X equals r times the cosine, y equals r times the sine. So I can plug in my theta value. Remember, it's r theta. So I'm going to plug in, for this, 0 for theta and evaluate. So the cosine at 0 is 1. 3 times 1 is 3. The sine at 0 is 0. Anything times 0 is 0. So this is going to be the rectangular coordinates. Okay? Notice that in polar, we're always going to have what? Yeah, the brackets and then parentheses for the rectangular. Okay, so for this one, very similar. The cosine at pi over 3 is 1/2. 2 times 1/2 is 1. And then 2 times root 3 over 2 is going to be root 3. And then I told you guys to keep that as an exact value for this. And then this is also similar. When you evaluate cosine at 7 pi over 6, you get negative root 3 over 2, which is going to simplify to negative 2 root 3. And for C, this is going to simplify to negative 2. Okay, any other questions for me on the first page